Okay, so I've put in two extra slides that are not in your note sheets. I don't know if you want to get a sheet of paper and write this. I don't know if you even need it. You can decide. So I pulled two examples from AP Calc just to help get us ready because to me IB just dives right in and I think it's a little more helpful for us to start with the basic stuff. So let's remember average speed we find by taking our distance traveled, the change in the y or change in d, divided by the length of the interval. All right, so a rock breaks loose from the top of a cliff. What is its average speed? Average is the slope of 2 points in the first 2 seconds. So the first 2 seconds mean I'm going from 0 seconds to 2 seconds. So let's figure out at 0, if I plug 0 into the equation that they give me for the function, I get 0. If I plug in 2 to the equation they give me, 2 squared is 4 times 16 is 64. So to find average speed, my distance is a function of time. So this is my distance, this is my time traveled. So average speed is 64 minus 0, change in distance, over 2 minus 0, change in time. So I get 64 over 2, which is 32 feet per second. Oops. So between 0 and 2 seconds, I averaged a speed of 32 feet per second. But now let's go to instantaneous speed. How fast is it going at exactly 2 seconds? So it's easy to find it if I'm going in an interval. So what we're going to do is we're going to say we're going to start at 2 and then I'm going to go sometime after 2. Let's say h amount past 2. All right, this is a little bit complex, but just bear with me for a minute. All right, so when x is 2, we're going to use our same function that we were using before, 16t squared. So if I plug in 2, I know this is 64. That was just what we used the last time. The 2 plus h is the trickier part, and this is where we're getting into more of the calculus part. Now, if f of t is 16t squared, what is f of 2 plus h? I'm replacing t with 2 plus h to find my y value. 16 times 2 plus h squared. Now, this is the tricky part. We got to simplify this side. So first I'm going to square my quantity. So 2 plus h squared, 2 plus h times 2 plus h, 4 plus 4h plus h squared. If you need to write that on the side and distribute it out, then I have to distribute the 16. All right, so this whole great big y value is that. All right, so hopefully you kind of see where I'm going when I get done. You might still have no clue what I'm doing, and that's okay. Now I'm going to take my change in y, or my change in distance, divided by my change in time. So if I just find the average of these 2 points, I'm going to take my y minus the y minus y, all over x minus x. Simplify the top. If you do this correctly, everything without an h will cancel. Simplify the bottom, and you will always have a single h on the bottom. Now, this is where we're going to talk about limits a little bit. If my time is in between 2 and 2 plus h, if I want the instant that t is 2, what does h have to equal for t to be between 2 and 2? Do you see how if h is 0, I can then plug, it's going to be between 2 and 2, which is exactly 2. See right here, I can't plug 0 in for h yet. We're going to take the limit as h approaches 0. But up here, this is where I said this is really important to cancel everything without an h, because now there is a common factor of h. So you factor out the h. This h cancels. Now I can plug 0 into what's left over, and I get 64. So my instantaneous speed is 64 feet per second at the exact value t is 2. Here, this was calculating the average speed. It was gaining speed, and in between 0 and 2, it traveled at a speed of 32 feet per second. So that leads us into our section D, and it talks about the gradient of the tangent, which also tells us instantaneous speed is always going to be this formula. The limit as h approaches 0 of f of a plus h minus f of a all over h. Let me write this where you can see it better. I'll be honest, this was the first time I started really freaking out in calculus. I had no idea what this guy was saying. But if I want to find the slope of the tangent line, and I can't estimate the slope because I got to find it exactly, we're going to use this formula. We'll get through this together. Let me show you how to do this. All right. So our equation is f of x equals x squared at the point 2, 4. So what we're going to do is use this formula. We're going to do the limit as h approaches 0 of f of a plus h minus f of a all over h. Now, this is really helpful. When x equals 2, that means I can replace these values here with 2. I can always plug in my x number right there. So I'm going to find the limit as h approaches 0 of f of 2 plus h minus f of 2 all over h. Now, our function is f of x equals x squared. I need to find, let's do the easy one, f of 2 is just 2 squared, which is 4, which, yeah, that's what that said. I also need to find f of 2 plus h. Which is 2 plus h squared. This is where we have to distribute 2 plus h times 2 plus h, which is 4 plus 4h plus h squared. All right, so we're going to take the limit as h approaches 0. Remember, f of 2 plus h equals all of this. So I'm going to replace this with what it equals, 4 plus 4h plus h squared minus, what is f of 2? 4, all over h. Now let's go back here. Remember what I said back here? This cancels, and you're always just going to have h on the bottom if we wanted an exact value. And everything on top has to cancel that doesn't have an h. So we end up in the same spot. So we have the limit as h approaches 0. Now, see how they have an h in common? I'm going to factor out an h because I can't plug 0 in for h right away. That was what we were leading to with those other examples. you first have to factor the GCF out so we can cancel the H. Then I can plug 0 in for H, and I get 4. What that tells me on the graph of x squared at the point where x is 2 and y is 4, the slope of the tangent line is 4. I can't estimate it. I have to find it algebraically using this, and it's a pain, but we won't use this process too much longer.